Number 19, a 500 kilogram rocket sled can be accelerated at a constant rate from rest to 1600 km per hour in 1.8 seconds. What is the magnitude of the required net force? Okay, what is the required net force? It is the sigma F in the Newton's law, right? So that will be, let's write our formula first. So sigma F is equal to mass times acceleration, right? And we are asked to find out what is the required net force here. Good. And let's write what we are given from the problem. I have the mass here. The mass is 500 kilograms. So let's write that. So we'll have the mass is 500 kilograms. Okay. And then it can be accelerated at a constant rate from the rest. So the V0 here is 0 meter per second. Okay. And then to 1600 kilometer per hour. So we will have our Vt here is 1600 kilometer per hour. But then we also have the time of the acceleration that will be 1.8 seconds. Okay, what is the problem here? We have this one here in kilometer per hour. We need to convert this into SI unit. Okay, maybe let's erase this first because we have to do some calculation first. Okay, so let's rewrite Vt on the SI unit. So I'll have Vt here that will be 1600 kilometer per hour. The SI unit is meter over second. Okay, right? So to convert from the kilometer to meter, we have to multiply this by 1000 because 1 kilometer is 1000 meter, right? And divide that by the hour here. So this is in meter, but 1 hour is 60 minutes, but 60 minutes is 3600 seconds, right? So we'll have 306,000 seconds. Okay, and we will have our Vt here. I think that will be the job of our calculator, right? So we will have 1600 multiplied by 1000 and then divided by 3600. Okay, and that will be 444. 444. I think this will be better. So I have 0.44 meter per second. Okay, but that is Vt here, right? But we need to get the acceleration to calculate the force. But remember that Vt here is Vo plus At, right? Remember the kinematics formula? Vt is equal to Vo plus At. Now let's plug this into this value here. What is our Vt? We will have 444.44. And Vo, it is starting from the rest, right? So I'll have Vo is 0 meter per second. So I'll have 0. And then we will have the acceleration. We are looking for the acceleration. And what is the time? 1.8 seconds. So I'll have 1.8 here. 1.8 here. And so we'll have 444.44 is equal to 1.8 A. And we can isolate A here. So we'll have 444.44 divided by 1.8. And I think that will be the job of our calculator again. So we have 444.44 divided by 1.8. Okay, that will be 246.91. Yeah, 91. And the unit here will be meter over second squared. Good. Now we have one of the most important values. Maybe let's clean up our slide first. Okay, now we need to answer the question, what is the required net force? So we will have sigma F here is equal to the mass times acceleration, right? And I think we can just plug that in. What is the mass? 500 kilogram. And then what is the acceleration? I will have 246.91. Okay, and then we can have that by calculator, right? 500 multiplied by 246.91. Okay, and I have 100. Okay, 123. Then 455. 455. And the unit here will be in Newton, or we can rewrite that as kilonewton here. 123.455 kilonewton. And that will be the required net force for the rocket sled that can be accelerated in that manner. Okay, and I think that's all for this problem. Thank you for watching. See you in the next video. Bye bye.